Hello everyone, so in this video I'll be explaining to you about classification of crystalline solids, crystal lattice or space lattice, unit cell, types of crystal systems. Moving on straight to the classification of crystalline solids. The crystalline solids can be classified into four types depending upon the nature of intermolecular forces operating in them. The first one, molecular solids. These are crystalline substances in which the constituent particles are molecules. The second one, ionic solids. These solids consist of positively and negatively charged ions arranged in a regular fashion throughout the solid. The third one, metallic solids or crystals. In metallic crystals, the constituent particles are positive ions called kernels immersed in a sea of mobile electrons. The fourth one, covalent or network solids or crystals. In covalent crystals, the constituent particles are atoms which are linked together by a continuous system of covalent bonds throughout the crystal. Now let us see a brief summary of the characteristics of various types of solids. As you can see on the screen, I'll be explaining you briefly. So the first one is the molecular solids, which is further classified into three types, that is non-polar, polar and hydrogen bonded. Non-polar solids are those solids which are held together by dispersion or London force. They are weak forces. Examples like solid carbon dioxide, argon, hydrogen molecule, iodide molecule, carbon tetrachloride and methane. The next one is the polar solids. Polar solids are those solids which are held together by dipole-dipole interactions. So examples like hydrochloric acid, SO2, sulfur dioxide. The next one is hydrogen bonded. They are held together by hydrogen bonds. Okay. So examples like ice, H2O. Then the second types of solid is ionic solids. Okay, so they are the positive and negative ions which are held together by strong electrostatic or coulombic force. Examples like NaCl, MgO, BaO, CaF2, ZnS, KCl, barium sulfate, lithium fluoride. Okay. The third one is the metallic solids. They are held together by metallic bonding, that is the electric attraction between the ions and electrons. So examples like common metals such as copper, silver, iron, magnesium and some alloys. The fourth one is covalent or network solids. They are held together by covalent bonding, which is the electron sharing. So examples like quartz, SiO2, SiC, diamond, AIN, graphite. Okay, now moving on to the next topic, that is the crystal lattice and unit cell. A crystal lattice or space lattice is a regular arrangement of the constituent particles, which may be atoms, ions or molecules, of a crystalline solid in three-dimensional space. A unit cell. A unit cell may be defined as the smallest three-dimensional repeating portion of a space lattice, which when repeated over and again in different directions produces the complete crystal lattice. It is also known as the building block of a space lattice or crystal lattice. Now let us see the parameters of a unit cell. A unit cell is characterized by its dimensions, which is the length along the three edges as A, B, and C. The edges may or may not be mutually perpendicular. The next one is angles alpha, beta, and gamma between the pair of edges. The angle alpha is between the edges B and C. The angle beta is between the edges C and A, and angle gamma is between the edges A and B. Thus, a unit cell is characterized by 6 parameters: A, B, C, alpha, beta, and gamma. The parameters of a unit cell are shown in figure, as you can see on the screen. The complete crystal lattice can be obtained by extending the unit cell in all the three directions. So now let's see the characteristics of a crystal lattice. The first point: each point in a crystal lattice is called lattice point or lattice site. Number 2, each point in a crystal lattice represents one constituent particle, which may be an atom, a molecule, or an ion. Number 3, the three-dimensional arrangement of lattice points represents a crystal lattice. Number 4, lattice points are joined by straight lines to bring out the geometry of the lattice. Let us see the types of crystal system. There are basically two types of unit cells constituting different crystal systems. They are primitive unit cells, centered unit cells. Primitive unit cells. These are unit cells which have points only at the corners. These are also called simple unit cells. The next one is centered unit cells. These are unit cells which have points at the corners as well as at some other positions. So the centered unit cells are of three types: face-centered unit cells, in which the points are present at the corners as well as at the center of each face; body-centered unit cells, in which the points are present at all the corners as well as at the body center of the unit cell; and centered unit cell, in which the points are present at all the corners and at the center of two opposite faces. When a unit cell in a crystal has lattice points only at its corners, it is called a simple or primitive unit cell. In all, there are 7 types of simple or primitive unit cell among crystals. These unit cells are characterized by the lengths A, B, and C, and the angles alpha, beta, and gamma. These are called 7 crystal systems or crystal habits. Let us see one by one. The first one is the cubic. All the 3 axes are of equal length and are at right angles to each other. That is, A equals to B equals to C, and all angles equal to 90 degrees. The next one is tetragonal. The 3 axes are at right angles to each other, but only the 2 axes are equal. That is, A equals to B, which is not equal to C, and all angles equal to 90 degrees. The third one, orthorhombic. It has 3 unequal axes, which are at right angles to each other. That is, A is not equal to B is not equal to C, and all the angles equal to 90 degrees. Fourth one, monoclinic. The 3 axes are of unequal length, and 2 angles are of 90 degrees. That is, A is not equal to B is not equal to C. 2 angles equal to 90 degrees, and 1 angle is not equal to 90 degrees. The fifth one, that is hexagonal. It has 2 edges of equal length, that is A equals to B, and 2 angles of 90 degrees, and one angle of 120 degree. That is, A equals to B is not equal to C. Two angles of 90 degree and one angle of 120 degree. Rhombohedral. The three axes are of equal length, which are inclined at the same angle, but the angle is not equal to 90 degree. That is, A equals to B equals to C, and all three angles equal but not equal to 90 degree. The next one is, which is the last one, that is triclinic. The three axes are of unequal length and all angles are different, but none is perpendicular to any of the others. That is, A is not equal to B is not equal to C, all angles different and none equal to 90 degree. Let us see the different possible variations for all these 7 crystal systems. The first one is cubic. As you can see on the screen, there are 3 possible variations for cubic system, that is primitive, body-centered and face-centered. Next one, tetragonal. There are 2 possible variations, that is primitive and body-centered. Third one, orthorhombic. There are 4 possible variations. They are primitive, body-centered, face-centered and end-centered. The next one is monoclinic. There are 2 possible variations, that is primitive and end-centered. Next one, hexagonal. There is only one possible variation, that is primitive. Rhombohedral, also only one possible variation, that is primitive. And the last one, which is the triclinic. This one also has only one possible variation, that is primitive. Let us also look some of the example for the following 7 types of systems or crystal systems. As you can see on the screen, cubic system example: sodium chloride, potassium chloride, zinc blend, copper, silver. Tetragonal: white tin, tin dioxide, titanium dioxide, calcium sulfate. Orthorhombic examples like rhombic sulfur, potassium nitrate, lead carbonate, barium sulfate. Monoclinic example: monoclinic sulfur, PbCrO4, Na2SO4, .10H2O. Hexagonal example like graphite, ZNO, CDS. Rhombohedral example like calcite, that is calcite, CSCO3, cinnabar, that is HGS, quartz, SB. Triclinic example: CuSO4, 5H2O, K2Cr2O7, H3, BO3. So these are some of the examples for the following different types of crystal system.